Hello friends, welcome to Dr. Acharya Academy. Today we'll discuss about the chemistry class 11 from the CBSE syllabus. Today's topic is mole concept and molar masses. If you till now not subscribed, please subscribe the Dr. Acharya Academy. Today class number is 008. First, introduction. Atoms and molecules are extremely small in size and their numbers in even a small amount of any substance is really very large. To handle this such large numbers, a unit is required. Just as we denote for the 12 number of items, 1 dozen, for the 20 number of items, it is score, and for gross, this is the unit for to mention the 144 number of items. And we use the idea of the mole to count entities at the microscopic level: atoms, molecules, particles, electrons, ions, etc. In SI system, mole, which is denoted by the symbol MOL, was introduced for the amount of a substance. 1 mole contains exactly 6.02214076 multiplied by 10 to the power 23 elementary entities. We will consider next time only 6.022 to simplify the number. This number is the fixed numerical value which is called the Avogadro constant, symbolized by the Na, capital N subscripts capital A, and it is expressed as the unit per mole, and then it is called the Avogadro number. The amount of substance, which is symbolized by the small n, is the measure of the number of specified elementary entities. An elementary entity may be an atom, a molecule, an ion, electrons, or any other particle. The mole of a substance always contains the same number of entities. So, when we will determine the number precisely, then we have to take the mass of the carbon 12 isotope, and it should be determined by the mass spectrometer to get the result very precisely, and then it will be the 1.992648 multiplied by 10 to the minus 23 gram. Knowing this value, the carbon, 1 mole of carbon weight the 12 grams, and the number of atoms in it is equal to the following calculation: 12 gram per mole of carbon whole divided by the 1.992648 multiplied by 10 to the power minus 23 gram per carbon atom, and then if you calculate, then it will get the value, Avogadro number value 6.0221367 multiplied 10 to the power 23 atoms per mole. So this number in entities of in 1 mole is so important, it gives a separate name and symbol. That means it is a separate name is the Avogadro constant and symbol is the Na. Many entities like atoms, molecules, or any other particles constitute 1 mole of a particular substance. Whatever substance is that, it's 1 mole of that particular substance contains that much number. As for example, for the 1 mole of hydrogen atoms has that Avogadro numbers of atoms 6.022 multiplied by 10 to the 23. In the same way, for the compound water molecules, its 1 mole contains same number 6.022 multiplied by 10 to the 23 molecular entities. and 1 mole of sodium chloride, another compound. It has the entity contains the 6.022 multiplied by 10 to the 23 formula units of sodium chloride. Because we know that for sodium chloride, we used to tell the formula mass. Now molar mass. By defining a mole, it is easier to know the mass of 1 mole of a substance or the constituent entities. The mass of 1 mole of a substance, if it is unit is gram, then it is called the molar mass. So it will be equal by number to the atomic, molecular and formula mass, and if you change the unit from U to the grams, then it will call the molar mass. So molar mass differentiate from the atomic, molecular or formula mass is its unit. For molar mass it is the gram, and for the atomic, molecular and formula mass the unit is a small u. So molar mass of water 18.02 gram dot mole inverse. For molar mass of the sodium chloride 58.5 gram dot mole to the power -1. Now percentage composition. Till now we are dealing with the number of entities. Now we will consider the percent of composition. Why? Because any unknown or new compound to you, and you have to ask that what is this formula, what is the constituent, and what is the ratio of the elements present in the compound. And for all this case, you need the percentage of composition of the elements in that particular compound to get its formula. So example, 1 mole of various substance, you can see in figure that different amount is there, but in each case, in each pot, the substance is the 1 mole. And when it is the known compound, then such information provides a check whether a given sample is pure or not, because we have to compare the percentage of composition with the pure samples of that known compound. So that means we can check the purity of a given sample by analyzing this data. So we'll consider an example of the water molecule H2O. In this case, the hydrogen and oxygen, the percent composition of both these elements is calculated as general formula. The mass percentage mass of an element is mass of that element in the compound multiplied by 100 whole divided by molar mass of the compound. If you consider this equation, in this case the molar mass of water we know 18.02 gram, and in this case the percentage mass of hydrogen, using this equation 2 multiplied by 1.008 multiplied by 100 whole divided by the 18.08. So result will be 11.18. And again the percent mass of the oxygen, in the same way if we calculate using the same equation, then 16.00 multiplied by 100 whole divided by 18.02, and in that case the result will be 88.79 for the percent mass of oxygen in H2O molecule. Another example, if we see that what is the percentage of carbon, hydrogen, oxygen in ethanol, we know the ethanol, its formula is C2H5OH, and molar mass of ethanol, if you calculate that here 2 carbons is there, so 2 multiplied by the 12.01 plus here 6 hydrogen is there, total 5 hydrogen plus 1 hydrogen, 6 multiplied by 1008, and 1 oxygen is there, so 1 multiplied by 16.00 gram, and if you calculate then you will find the 46.068 gram is the molar mass of the ethanol. And then the mass percent of carbon after the calculation using the same equation we used to calculate the hydrogen and oxygen percentage in H2O molecules, then you will get the result here. You can see that 2 number of carbon is there, so 2 multiplied by 12.01, that means 24.02 gram multiplied by 100 whole divided by the molar mass of the ethanol here 46.068. So result will be the 52.14% of carbon present in the ethanol. In same way, if you calculate the percent of hydrogen, then the answer will be after calculation 13.13%. Here you can see that the 6 hydrogen is there, so 6 multiplied by the 1.008, then result will be the 6.048 multiplied by 100 whole divided by the molar mass of the ethanol 46.068, and then the final result will be the 13.13. And in same way, if you calculate the percent of the oxygen in the ethanol, then result will be the 34.73%. Now empirical formula for the molecular formula. An empirical formula represents the simplet whole number ratio of the various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. If the percentage of mass of various elements present in a compound is known, then its empirical formula can be determined easily. The molecular formula can further be obtained if the molar mass is known.